Hello everyone, welcome back to my physics learning channel. I am Hiranmaya Mahapatra and today's lecture will discuss one of the most fascinating inventions in modern science, the laser. In this video, we'll cover history of lasers, difference between ordinary light and laser light, basic principle of laser action, population inversion, types of laser and applications. So let us start. The word laser stands for light amplification by stimulated emission of radiation. A laser produces a highly intense, monochromatic, coherent and directional beam of light. The first successful ruby laser was developed in 1960 by Theodore H. Myman. The invention revolutionized science, communication, medicine, manufacturing and defense technology. Let us first understand how ordinary light differs from laser light. In ordinary light, light coming from a bulb or lamp, it contains many colors or wavelengths and it is not coherent. It spreads in all directions. It is less focused. That is why ordinary light appears scattered. The laser light has unique properties. It contains only one wavelength, so it is monochromatic. The waves are coherent, meaning they remain in phase. The beam is highly directional and it is sharply focused and intense. Because of these properties, laser light can travel long distances without spreading much. Fundamental components of a laser. A laser system mainly consists of three parts. First one, active medium. Active medium provides optical amplification. It may contain atoms, molecules, or ions in solids or gaseous form. Examples include ruby laser, helium neon gas, semiconductor laser. Then coming to pumping source or optical resonator. So pumping source supplies external energy. Pumping source supplies external energy to excite the atoms of the active medium. The energy may be provided through electrical discharge, optical pumping, and chemical reactions. In optical resonator, it consists of two mirrors placed facing each other. One mirror is fully reflecting and the other is partially reflecting. The light repeatedly reflects between these two mirrors and gets amplified and finally emerges as a laser beam. So this is the schematic of a laser. This is the lasing medium or amplifying medium and this is the pumping source. At the two ends you have two mirrors are there. So let us understand the basic principle. There are three important processes. First one is absorption. So in absorption case, consider an atom with two energy levels. Lower energy level is E1, higher energy level is E2. When a photon, when a photon with energy h nu strikes this atom, the atom absorbs this photon and moves from E1 to E2. This process is called absorption. The second one is spontaneous emission. An excited atom cannot remain stable for long. So it automatically returns to the lower energy state by emitting a photon. This emission occurs randomly and is known as spontaneous emission. In this case, the emitted light is not coherent. Then coming to the third one, stimulated emission. This is the most important process in laser action when an incoming photon interacts with an excited atom, it stimulates the atom to emit another photon. So the emitted photon has same frequency, same phase, same direction, same wavelength. As a result, coherent amplification of light occurs. This process is called stimulated emission. So in laser light, stimulated emission occurs. So this is the difference between spontaneous and stimulated emission. There are different points. Then coming to another important process is population inversion. So in population inversion process, normally most atoms remain in the lower energy state. But for laser action, more atoms must occupy the excited state than the ground state. This condition is called population inversion. So this condition is achieved using pumping mechanisms. So without population inversion, laser action is not possible. So there are different types of lasers: solid laser, liquid laser, gas laser, dye laser, semiconductor lasers. So it works on the principle of different level systems, 4-level system and 3-level system. So Ruby laser is the material. It is the combination of Al2O3 plus Cr2O3, aluminum oxide, chromium oxide. It is a crystal, and the color of the rod is pink. The laser material is ruby rod. So this is the ruby laser structure. So you need optical pumping source here, flash tube, and you will get laser light at the output end. So what is this labeling procedure? So in this case, the atoms are excited to higher energy states, and it quickly moves to the metastable state, and population inversion occurs between metastable state and lower state. So stimulated emission produces laser light. So this is a efficient lasing system which is used in ruby laser. So these are the drawbacks of ruby laser. The laser requires high pumping power. The efficiency of ruby laser is very small. So use of ruby lasers are used in optical photography. It can be used for measurement of plasma properties. Ruby lasers are used to remove the melanin of the skin. A ruby laser can be used for recording of holograms. Then coming to the helium neon laser, the material is glass. Helium and neon ratios are 10:1. In this case, you need electrical supply, power supply you need as a pumping source. So here it is a 4-level resin system. This is most efficient than 3-level resin system. In this case, atoms are excited to higher energy state and they quickly move to the metastable state. Population inversion occurs between metastable state and lower state, and stimulated emission produces laser light. In this state, E3 to E2, so stimulated emission produces laser light. The laser diode is a semiconductor laser diode. It is a semiconductor device that directly converts electrical energy into light. It works using a PN junction diode. When electrons recombine with holes, photons are emitted. Initially, spontaneous emission occurs. With continuous excitation, stimulated emission takes place, producing coherent laser light. So this is most efficient laser which is used in optical communications. So laser diodes are widely used in optical communications and laser weapons, laser targeting, and guided bomb lasers, laser used for tattoo removal process. Lasers are used in manufacturing. Lasers are used in industries as a cutter. And welding purpose, you can use laser light. And eye surgery, you can use laser light. And laser barcode scanners, you can use. Then telescope calibrations, you can use laser lights. So lasers are most efficient in communications, fiber optic communication system. The lasers have numerous applications in different fields. So lasers are used in, I have shown in the diagrams, laser targeting system, laser guided weapons, smart bombs, guns. The laser beam helps accurately identify and track targets. So in industries, it is used for cutting purpose, welding purpose. In medical application, it is used for eye surgery, dentistry, tattoo removal. Communications used in laser communication or fiber optics communications. So lasers are also very useful in telescope calibrations to reduce atmospheric disturbances and obtain sharper images. So in today's lecture, we discussed about introduction to lasers, difference between ordinary light and laser light, process, stimulated emission process, population inversion, and different types of lasers and its applications. So lasers have become an essential part of modern technology and continue to influence science, medicine, communication, and industry. Thank you for watching this lecture. So these are the references. I have used various text, figures, simulation, other educational resources from online platforms. If you found this video useful, please like, share, and subscribe to the channel for more physics lectures. See you in the next video.